These problems will look at different styles of problems that were looked at on reference guide entry number 3 in Unit 2. So on that reference guide, we looked at problems that involve multiple right triangles. We looked at very specific types of questions on that reference guide, but there are other forms that these problems can take. And I wanted to do a quick video to show a couple of those other forms, just to see the variations that the problems may have, so that you can better solve them should you see similar problems to these two somewhere down the line. So the first problem reads, a blue jay and a cardinal are perched at the top of two trees with an apple in between. The apple is 10 meters from the tree in which the blue jay is perched, and there's an angle of inclination of 31 degrees from the apple to the bird. The tree in which the cardinal is sitting is 9 meters tall, and the angle of inclination from the apple to that bird is 41 degrees. Determine which bird is closest to the apple and by how much. So the first thing we want to do is just do a sketch, just like we always do. So we're going to have two trees, and we're going to have an apple that lies somewhere in between. And we'll start with the blue jay. Well, we know that the blue jay, the apple is 10 meters from the tree in which that bird is perched. So we're going to label the base as 10 meters. We know that the blue jay is up here. And we know that we can make a right triangle. So it will look something like this. The other part of information, or the other piece of information that we know about that right triangle is the angle of inclination is 31 degrees. And we want to know how far the blue jay is from the apple. Well, we're going to take the most direct route to figure that out, which would be the hypotenuse of this right triangle. So we have a right triangle to represent the blue jay that looks something like this. Now we move to the cardinal. Well, we know that the cardinal is at the top of the tree and that the tree is 9 meters tall. So the cardinal is going to be up here, a distance of 9 meters. We can then connect the right triangle to the apple, and we know that the angle of inclination is 41 degrees in this case. So we know different information about the two triangles, but we're solving for the same thing. We're solving for the hypotenuse in each case. So there's what our diagram would look like. The blue triangle is for the blue jay. The red triangle is for the cardinal, which is red. And now we're going to have to solve these problems. So let's start with the red triangle. Well, we want the hypotenuse. And if we label our known side, it's clear across the triangle from our angle. So it's going to be the opposite side. So we're going to use the trigonometric ratio that involves the opposite side and the hypotenuse, which is sine. And if we're finding the hypotenuse using the sine ratio, and again, remember that your magic triangles may tell you this, or you may just manipulate the formula, whatever you prefer. The hypotenuse is equal to the opposite side divided by sine of the angle. The opposite side we've identified to be 9 meters. The angle we know is 41 degrees. So to find the hypotenuse, we're just going to divide 9 meters by the sine of 41. And when we put that in our calculator, it gives us 13.72 meters. So the cardinal is 13.72 meters away from the apple. Now we're going to do the blue jay. Well, the blue jay's triangle does not involve sine because the known side is the adjacent side in this case. So we're going to use the trig ratio that involves hypotenuse and adjacent, which of course is cosine. So to find the hypotenuse using cosine, it's adjacent over the cosine of theta. So now we're going to fill in our values. The adjacent side is 10 meters. Theta is 31 degrees. So the hypotenuse, therefore, is going to be equal to 10 divided by cosine of 31, which gives us 11.67 meters. And there, we've answered part one of what the question is asking. It's saying which bird is closest, which is the blue jay. Its distance is less than that of the cardinal, so it's closest. But then the second part says by how much. Well, we would find that out by subtracting. So to find the distance that the blue jay is closer than the cardinal, we're going to take 13.72 I'm going to subtract 11.67, which should give us 2.05 meters. Now, the question doesn't tell us how to round. It doesn't say to the nearest tenth of a meter or anything like that. So, as we've discussed in previous reference guides, if the question doesn't tell us how to round, we go to the nearest tenth of a meter. And that would round this to 2.1 meters. And then we have one step left. With any word problem, you would write a concluding sentence. And we would say, therefore, the blue jay is closer by 2.1 meters. Okay, and it's important to recognize once again that in this problem, it is more complicated because there is more information to make sense of and to put in your diagram. But at the end of the day, you're just using your trig ratios. You have to use them twice in this case, but at the end of the day, it is just a sine problem, a cosine problem, and then at the very end, a subtraction problem. So that was the first question. Now let's look at another way that these questions could be presented to you. An observer looks out the window of her apartment building at another building across a parking lot. The angle of depression to the base of that building is 37 degrees, while the angle of elevation to the top of that building is 48 degrees. If the observer is 21 meters high, calculate the height of the other building. Well, we don't really know which building is taller. We know that the other building is higher than the observer. So it doesn't really matter how we draw our diagram, so long as everything is accurately labeled. And I'll put my observer right there. So my observer is 21 meters high. Well, now we need to use our angle of elevation and our angle of depression to see if we can come up with two right triangles. Well, let's start with the angle of depression. We know that angle of depression exists underneath a horizontal. So let me draw the horizontal in, and then this line would be her line of sight. So we can see how our right triangle forms there. And we put our angle of depression in the correct spot. It's 37 degrees, and it's right there. Now, although it's not written in the question, if we look at our diagram, we know something else about that red triangle. We know that the vertical leg is also 21 meters, because the horizontal would be directly across. Now, let's look at the angle of elevation. Well, the angle of elevation to the top of that same building across the parking lot is 48 degrees. So we know that we can then put a blue triangle that would look like this. But the only thing we know about the blue triangle is that the angle of elevation is 48 degrees. We don't know anything else about it. But we set up our diagram so that it looks like this. And when we look at this, it looks like we don't have enough information. We know that part of the height of the other building is 21 meters, but there's something on top of it. There's some other value that when we add to 21 will give us the entire height of that building. We will hopefully think back to reference guide 3 at this point and remember that shared sides are important. And there is a shared side here. There is a shared side right there where the blue and the red overlap. So if we find that side, which I've just labeled as y, well then we could plug that in on the blue triangle and then find x, and then add x to 21 and get our answer. So let's do that. So we'll start just by finding y on the red triangle. So 21 meters is clear across the triangle, so it's going to be opposite. And the shared side will be adjacent for the red triangle. So we are going to need to solve for adjacent. So we're going to be using tan because it's opposite and adjacent. Adjacent is equal to opposite over tan theta. So adjacent, therefore, is equal to 21 meters over the tan of 37 degrees. And adjacent then, when we put this into our calculator, 21 divided by tan of 37 is 27.87. So all that's telling us is the horizontal distance from where this observer is looking straight across to the other building is 27.87 meters. But now we have that link that will allow us to solve our blue triangle. So we just found the adjacent side of the blue triangle, which means that the spot we've labeled as x, the vertical leg of the blue triangle, will be opposite. So if we're solving that, we're again using the tangent ratio. We know adjacent, we want opposite this time. And opposite is equal to tan of theta multiplied by adjacent. So our opposite is equal to tan of our angle of elevation, which was 48 degrees, multiplied by our adjacent side, which we found to be 27.87 meters. So our opposite side, therefore, is tan of 48 multiplied by 27.87, which is 30.95 meters. So that means that on top of the 21 meters that's already known, we add 30.95 more meters to that to give us the full height of the other building. So we know that she's 21 meters high, so we've accounted for that already. But we know that based on the vertical distance above the horizontal at which she's looking, we can add 30.95 more meters to that value, which gives us 51.95 meters. And again, we look, and it doesn't tell us how to round. Well, that means we round to the nearest tenth. And that's going to actually make this thing an even 52.0 meters. Now, it's a word problem, so once again, we write our ending, or we finish it off with a concluding sentence. So we would say, therefore, the other building is 52.0 meters tall. Okay, and those are just two additional ways that these problems could look. So now you've seen examples of three different styles of problem. Hopefully that will help you anytime you're faced with multiple right triangles moving forward.